our next question is also geomorphology. So let's just quickly move on to our next question. And if we look at figure 2.5, we're dealing with river profiles. Okay. And I just quickly want to see, we got this question from, sorry, I just want to sort this out quickly. We've got this question from Kez. Yes, Kez. So, if we look at river profiles, I'm going to explain this question similar to the previous question, because what you see in front of you, basically, if you understand your concepts and if you look at your labeled diagrams, most of the answers is right in front of you. Okay, so what we have here, we have two different river profiles. Now, first of all, we got an original longitudinal profile, and then we got a new longitudinal profile. But I want you to pay attention over the time. They've mentioned over here over time. So what they're basically telling me, A is turning into B. Okay. And if we look at this profile, it has changed from a smooth concave slope to an uneven river profile, as you can see. Okay, so as you can see, A is beautifully concave in shape, and A has turned into B, and it's uneven. It's not beautifully shaped like A. Now, if we look at the information, the labels, they've mentioned the base level. At the ocean, it's still there, the base level. And there's a new base level being added at diagram B. And this base level is a dam wall. And then I also have mentioned the deposition of sediments. Now, there's a lot of information that's been given to us on this diagram, and I'm quickly going to explain it to you. Now, first of all, if you look at the longitudinal profile, okay, first of all, let's just define the longitudinal profile of a river. It's basically a side profile of a river from the source to the mouth. Okay, it's a side, it's like a cross section. You know, we're drawing a side profile from the source to the mouth. That's a longitudinal profile. But in this case, we have two different types of longitudinal profiles. The first one, like I've mentioned, is a smooth concave profile. And when the profile from the source, where the river originates, to the mouth into the ocean, where it flows into the mouth, right? So the river originates from a source and then ends up in the mouth. But as you can see, it's a beautiful, smooth profile. When it's a smooth concave in shape, we say it's a graded profile. Okay. Now, when we talk about graded profiles, we can almost say the river has reached equilibrium. There's equal amount of erosion and deposition that's taking place along the course of the river. Now, this is quite vitally important as well. Now, remember, we take our longitudinal profile and we can divide it up into 3 stages or 3 courses. Okay, I'm going to do it with the top one. Now, we have the upper course. We have the middle course, and we have the lower course. Okay, now this is vitally important because there's different erosional capabilities and factors that's happening at each of these courses, right? First of all, it's erosion, okay. And we do experience deposition as well, but that's in the lower course. We have different characteristics. We have different landforms. That's vitally important as well. Okay, so I just really quickly want to go back to this longitudinal profile. So, as you can see, it's a smooth concave in shape, right? Now, the river originates from the source. Now, the water volume is not as great like in the lower course, because what happens? As we continue to the middle course, what happens? Tributary starts joining. So what happens? The volume of the river increases. The velocity of the river increases. Okay, vitally important. But remember, have a look. Look at the gradient. It becomes less steep. It's almost flat at the lower course. Now, very importantly, I'm just going to add these notes over here because they might ask it on Friday. We experience vertical erosion at the upper course. We experience lateral and vertical erosion at the middle course. Why vertical erosion? Because it's steep at the upper course. Okay. Now we add more water because tributary starts joining at the middle course. So what happens? More water joins the river starts to widen. Okay. More volume of water, the gradient can still be steep, it still deepens. But what happens at the lower course, right? There's no erosion taking place, but deposition. Okay. Now, excuse me. Now, coming back to my graded profile, a big tip that I can have you over here, and I've mentioned over here, the base level. Now, that means the ocean, the only base level of erosion taking place where the ocean is, where the river flows into the ocean. And what do we call it? We refer to it as permanent base level of erosion. Okay. Now, as you can see, it's permanent base level erosion. Nowhere else do we have a temporary base level erosion or a nick point that's been created. So this is the final place where erosion takes place, and it's known as permanent base level of erosion. Now, that's our beautiful graded profile. Now, first of all, over time, like the diagram figure shows us, what happens over time? It turns from a graded profile to an ungraded profile. Because the profile was beautifully concave and smooth. But now we created a nick point. Now, if you look at it, as you can see, this river is not beautifully concave and smooth, is it? No. We, as humans, created a dam wall. Now, this dam wall, also known as a nick point. So what we have done here, the humans, they basically built a dam over here. They created an uneven longitudinal profile. And when it's uneven, we say it's an ungraded profile. Okay. Now, keep in mind, permanent base level of erosion will always be at the mouth. So it stays permanent base level of erosion. At the mouth of the river. But the dam wall that's been created over here, they've created a temporary base level of erosion. Okay. Why? Because they created a nick point. So it means what basically is going to happen over here. I've mentioned the reason why it's so beautifully concave with the graded profile is because there's an equilibrium. You know, the erosion and deposition cancels each other out, or basically same effect. But now with the dam being created, we might experience more erosion, or we experience more deposition. Or deposition is taking place where it shouldn't take place with a normal longitudinal profile. So the dam wall is being created right up in the middle course. So what happens? What's going to happen with the volume of water? It's going to build up, right? It's going to increase over there. Obviously, below the middle course, what's going to happen? There's going to be less volume of water because of the dam being built over there. Now, they've mentioned the deposition of sediments. Now, usually deposition of sediments takes place in the lower course, but now it's taking place in the middle course, right? So the equilibrium is completely disrupted by the dam wall that's been created over here. So that's our river profiles. That's what's been given to us. They showed us a beautifully longitudinal profile from point A to point B. It's beautifully shaped, known as a graded profile. And then we've got an uneven profile. It's known as an ungraded profile. Very importantly, we have created with the dam wall a nick point. And the nick point is a temporary, temporary base level of erosion. Okay. But ultimate or permanent base level of erosion will always be where the river enters the ocean. But let's have a look at the questions that's being asked. Okay. Now, if we look at this question, the first question, and I've mentioned it to you before, if you look at the first question quickly, it says, define the term longitudinal profile. Now, when we look at the longitudinal profile, it's from the source to the mouth. Okay, I want to go back to my image over here. It's from the source to the mouth. It's a side view. Okay, define the term longitudinal profile. I'm just going to write my answers there down at the bottom. 2.5.1. It's a side view of a river from the source to the mouth. Okay. Now, like I explained earlier, 2.5.2, describe the shape of the longitudinal profile A. Okay. First of all, I've mentioned it's concave. We can also mention it's very steep in the upper course, less steep in the middle course, and gradual in the lower course. So, I'm just going to write the correct term over there, and we're going to say it's concave. It's got a concave shape, and I'm just going to, for you to remember, we refer to it as graded. Okay. Now, 2.5.3. Identify the ultimate, permanent, and temporary base level of erosion in the diagram. Okay, I love it because I've just explained it to you. So it's quite easy to go and find the answer. Now, as you can see, longitudinal profile A. Permanent is the ocean, the sea. Permanent is the ocean. Now they asked, name the ultimate and the permanent and the temporary base level of erosion. What's the temporary base level of erosion? It's a dam wall. Okay, so let's just write it down there. I prefer to use the term permanent instead of ultimate, but you can use either. The permanent is the sea. I just want to go back. I'm going to highlight it with green. Okay? I've used green before. I just want to point it out. See, there's the permanent base level of erosion. It's the sea. Okay? But what did we as humans do when we constructed the dam wall? We create temporary base level of erosion. Okay? So just right there, the temporary is the dam wall. Okay? Or the dam, just the dam. Now, if we look at question 2.5.4, how will deposition of sediments influence the capacity of the dam? I love this question. Excellent question. Now, sediments, okay, I just want to clean my image a little bit over here. Okay, let me just quickly explain this question to you. Now, they want to know, how is the sediments going to influence the capacity of the dam? Now, first of all, keep in mind, what happens in the upper course, I've mentioned to you. Vertical erosion. What is erosion? Okay, it's the broken down of material. So the water transports the broken down material further down. Okay, it's like soil. Running water is an agent of erosion. So it's going to transport the broken down material because of the velocity, because of the movement, the steepness of the slope. So what's going to happen in this dam, especially in this upper course? Now, all that material that's being eroded, what's going to happen? It's going to be deposited inside this dam. Okay, we're talking about soil being deposited. So what's going to happen? Right? Eventually, so much soil are being deposited into the dam, it's going to start silting up. So what's going to happen with the capacity, the water capacity of the dam? Okay, it means the capacity of the dam is going to decrease. And when we talk about the capacity, we're talking about the water capacity. So eventually there's going to end up more silt, okay, more sediments because of the erosion that took place in the upper course. So let's see what we're going to write. How will the deposition of sediments influence the capacity of the dam? First of all, it's going to decrease the water capacity. So it's going to decrease the water capacity. You can also say, excuse me, reduce the volume of water. Okay, let's move on to our next question. 2.5.5. Describe the difference in grade between the new longitudinal profile and the original longitudinal profile. Love this question because we've just discussed it earlier. Just want to clean up a little bit over here. Now, well, it will ask, discuss the grade or name the grade of the new longitudinal profile and the original longitudinal profile. The new longitudinal profile is uneven, so what can we say? B is known as an ungraded profile because it's got a nick point in it. And A, the original, was a graded profile because it was smooth and concave. Now I'm just going to write there, the ungraded profile is uneven and it does have a nick point. Okay, so if we have a look at it, like I've mentioned to you, and very importantly, I want to add over there, right? The graded profile only have permanent base level of erosion. Okay, going back to our image. As you can see, look at the graded profile. First of all, smooth, check. Okay, right? No nick points, check. Only permanent base level of erosion that's being experienced. Okay, referred to a graded. Now, if we look at an ungraded profile, first of all, it's uneven, as you can see, check. It's got a nick point, check. Temporary base level of erosion, check. Permanent base level of erosion, check. That's how you differentiate between a graded and an ungraded profile. Okay, let's just quickly have a look at our next question. 2.5.6, explain the impact of the presence of the dam on erosion and deposition. Okay, I like this question because erosion and deposition is two different things. So, how is erosion, I'm going to write it there, and deposition, what impact is erosion going to have and deposition going to have? Now, first of all, going back to my diagram, the impact of erosion of this dam. Erosion is the transporting of broken down material. Now, first of all, there's going to be more erosion upstream. Okay. The simple reason why, because there's greater volume of water. I'm just going to write the answers on here. So if you increase the volume of water, you're going to increase the erosion capabilities, definitely. Okay. Now there's going to be more erosion. We can also mention the erosion temporarily stops at the dam, so this is where it ends because it fills up over here, right? And then what happens, especially down the dam wall? Now remember, we have removed the volume of water below the dam because of the dam wall. So what happens over here? Less erosion below the dam. Okay. Now, it's vice versa. What happens with deposition? There's going to be less deposition below the dam because there's no water flowing over there, right? And what happens over here? More deposition, and it might lead to silting up of the dam.